short description about the German German treatment of waste as a form of recycling. The next, please, the next. That's a short overview of my presentation. I have 4 points: legal requirements of recycling, all very short because the time is running. Then something about the terminal processes we can use also for the recycling, and then 2 examples in Germany, and at least the summary and the outlook. Yes, I start directly with the first one because of the time. In Germany, we had since since 4 years, very strict regulations about the dumping, about the treatment of waste with organic contents. It is forbidden to dump these wastes. The limit is at about 3% of the ignition loss. Waste with higher ignition loss are not allowed to be dumped. So we had to recycle them, or the other possibility is to incinerate them. But this means in the special cases the domestic wastes. And so in Germany we needed plants for incineration of domestic wastes. On the other hand, there is an exception in that law from the year 2001. This exception says waste which are biological treated with mechanic biological treatment, they may be dumped. That is an exception, and because they have higher ignition losses than 3 or 5%. This is a real exception for the domestic waste, and we are not very lucky with this because it is a political decision. And in Germany there only exist a few plants for this kind of treatment. So the real aims are the recycling and the incineration of the waste with higher contents of organic material. Then I gave you a very short description of the word recycling. We have the material recycling, you know it, I'm sure. Then the raw material recycling and the energetic recycling. Please, next. Yeah. We said that the raw material recycling is, in respect to the legislation, equal than the material recycling. It is, yes, maybe the same. Now I come to the first example, the example of the laws. Yes, that is the End of Life Vehicle Act from the June 2002. Next, please. Yes, that are the recycling criteria, and I want to show you only some few figures from this January. The end-of-life vehicles have to recycle for 80%. That means especially 70% recycling of the metal in material way. Then 10% in material recycling of the dismantling process, and the rest is 5% recycling, energetic or material or raw material, as you like, of the residues of the shredding process. That is the situation today from the January of this year. It will change in 9 years. Yeah. Then we have stronger requirements, especially on the shredding process and the residues. And these residues, 50%, are divided in a recycling ratio. That means 5% have to recycled in material way, and the rest, the 10%, can be recycled energetic or material or raw material. But this is in 9 years. The next example, please. This is our famous audience of the avoidance and recovery of packaging wastes. Next, please. Yeah, here you have the contingents of packaging material which had to be recycled. Next. Next, please. Oh, sorry. Yeah, thank you. This had to be recycled in material or raw material way. It was interesting, especially for the paper and cardboard and the composite material, because with this parts we have no problems. Yeah, we have in the thermal process of recycling, next please, and the same. Yeah, we have three methods to three different thermal processes. The incineration, here is only energetic recycling possible because you you transform the material to heat and nothing more, only to heat. Then the pyrolysis, that is energetic or raw material recycling is possible, and the gasification with energetic or raw material recycling. I showed you the two examples before only to say that we have to use these processes for the recycling, because there doesn't exist methods and processes for material recycling, for example, of composite material or the shredder light fraction. So we have to use these and these processes to fulfill the required ratios of recycling. We needed it. And in future, the importance of incineration, of pyrolysis and gasification will increase. Yes, the next please. Yes. The pyrolysis, you know it surely, that is heating without any air, and we get some products, tire and oil, and we can use it in material way. Gasification, hardly the same, and exception always is the use of the material, of the waste material in blast furnace. One can use the carbon as reduction material, and this is the same as a material recycling. But this is first the beginning of this recycling way, especially for shredder-like fraction. We have the gasification and the blast furnace processes. Next, please. Yes, now I come to the first process. That is a Kontern pyrolysis plant in Hamm in North Rhine-Westphalia. This plant is connected with the operating of a great power station plant, a slag temp plant of above 769 megawatt. And the pyrolysis plant is for the treatment of about 100,000 tons per year of wastes. This is an example only for energetic recycling in Germany. Please, the next one. This is a picture of the power plant Westfalen. I do not know where the Kontern plant is. I mean maybe here in this section. It's very near because you need very short ways for the gases. So it must be very close to the power plant here. Yes, I will give you a very short description of this Kontern process. Next, please. This is a plant. Here comes the waste. This is a lock system, a charging system, and then we have two rotary kilns, or pyrolysis drums, as one said. They are built with external heating, and the material here is heated to about 500 degrees without any air. The throughput of one rotary kiln is about 13 tons per hour. We have two of them. Then the material will split and crash into their components, and the rest of this process will be discharged here, and we get the gases with tar and oil, and the solid residue, that is coke, inert material like stone and so on, and the metal. The metal and the inert material is separated from the coke and can be recycled. The metal is of very good quality, and the coke and the pyrolysis gases with the tar and oil goes to the existing power station and is a substitute of the fuel, and in this power plant, in this unit, it substitutes about 10% of the hard coal. That is, I think, very much. But the input here is also very much, it is 100,000 tons per year. Yes, next please. Yes. The problem is the power plant had not the special facilities for gas cleaning like a normal incineration plant for waste, and so one had to look that the waste they get into the plant are of very good quality. You cannot treat in this plant wastes with high contaminated parts. But on the other hand, this system had some characteristics and advantages. Next, please. Yes, you can use the existing infrastructure of the power plant and all the facilities of the power plant. You had not build and operate a new plant with all these facilities. You had only to build the pyrolysis section. Next. Yes, as I said, you get the metal of the waste in a very good quality without any oxide. Next. Yes. The power plant has a very high temperature of 1500 degrees, and so that means all the organic pollutant like dioxin, PCBs and so on will be completely destroyed here at this temperature. And you can use the very good and high energy efficiency of the power plant. Normally the waste incineration plant have about an efficiency degree of about 20%, and that is very few. But the power plant fired with coal, they have much higher, about 38 to 45, and you can use it. And you have all your residues in the melted residues of the power plant. That means the heavy metals you have in the waste, they are later in the slag, in the molten slag of the power plant. That is very great advantage. Yeah. Now I come to the second example. That is the gasification plant. It operates for 300,000 tons of waste, and you can use very different waste: solid, liquid, pasty, fractions of domestic waste and hazardous waste. And the produced synthesis gas or syngas is in this process a feedstock for a connected methanol production. So that means it isn't an energetic recycling, it is a raw material recycling. As we in Germany said, it is equal than the material recycling. That means that for example, the packaging waste, as I showed you before, can be treated here in this plant to fulfill the requirements, the legal requirements of the recycling ratios. Yes, the SVZ process is an example for material recycling. Next, please. Here I gave you an overview about the mass input of the year 2003. Here are the wastes. 50,000 tons of liquid and solid waste. Some coal, that is about 20%. Now the ratio of coal is lower. And you produce with this input 380 million cubic meter of syngas or synthesis gas, and with this synthesis gas you can produce this amount of methanol, 80,000 tons, quantity of electricity and steam for the internal process and the slag. But I've later on mass balance a little bit more with more details. Next, please. Yes, the SVZ process is very much flexible in respect to the waste quality and the content, because this process here is a real waste incineration or waste treatment with all the requirements, the legal requirements on the gas control of the waste incineration plants. So they can take in the input sewage sludge, shredder light fraction, plastic waste, contaminated wood, electronic waste, these sorted fraction from domestic refuse, that's the packaging waste, and here we have the shredder light fraction, the tar sludge. This plant is located in the east part of Germany, in the former German Democratic Republic, and they have very much of these tar residues, and they can treat it with the plant. Then lac and paint remainders, liquid and pasty industrial wastes, like these. It is a very flexible process. Next, please. Yes, and now I show you the characteristics, the values for the waste that you can accept for this process. Here are the values, and here you see the components. It is, I think it's very high. For example, the PCB. I knew that the PCB is a limited value in other process, but very deeper. Yes, that is a flow sheet of the total process. We have here the gasifier. We have 3 systems of gasifier, but I will later give you details later. Here are 2, and here are 1 system. Then the raw gas of the gasifier go to the gas cleaning. That is the synthesis gas. That is carbon dioxide, carbon oxide, little bit methane, hydrogen and water. This gas is cleaned there. Some of this gas you cannot use, but you will use it only as a relaxed gas for energetic recycling here in a boiler, and there you get the steam. And the other gas, the main stream, you will treat in the methanol distillation. That is a normal methanol distillation process. So I will not describe this process, but it's a very normal process. Next, please. Yeah, that are the gasifiers. We have in this plant 5 solid bed pressure gasifier that are old ones. They were in former times developed for the treatment of coal, but now they changed the operating conditions and they can gasify the wastes. Then we have 2 fly stream gasifier. It is also old. They are also old gasifiers, and that is a very new one, the slag bed, and you see this great flow rate, 35 tons per hour. Yes, all the others you can, other values you can read here. Next, please. The slag bed gasifier is for special interest because it was especially developed to incinerate, to gasify the wastes in this plant. It is a co-development between the British Gas and the German company Logi for the gasification now of coal. This gasifier is since about 3 years in the large-scale operation. Yes, here you have a small picture of it. That is a charging system, the gasification system with a high temperature, and to gasify with a mixture of oxygen and steam. Steam and oxygen you give in and gets a high temperature. And the special difference to the other gasifiers is this discharging system with a special burner. So you get a slag. That is an example for a mass balance for 1 ton of plastic waste. The gasification of 1 ton of plastic waste, here you have the 1 ton, gives you the following products. At first, the interim products, that means the synthesis gas, 800 kilo relax gas, some water, and then at least the final output, you get nearly 600 kilogram of methanol. That means 24%, about 24%. Then you have the purge gas of the methanol process, is 265 kilo and about 10%. That is energetically used. And then you have the waste gas and the waste water, and so you got this is a main product in methanol with this purity of 99%. Next, please. And here we have some, the same example, some values of the energy. You give in these systems an input with a plastic waste of 9 megawatt, 9.36 megawatt, and you will get out with a methanol fraction about 3.31, that is 35%, with electricity about 10%, and with the heating energy about 3%. So you came to the sum of about nearly 50% as an energy efficiency of this process. But you must remember it is a mixed efficiency, because this is material and this is energy. Yes, it is difficult to determine such efficiency. Thanks. Oh, next. Yes, that are the special characteristic of this process, and I have here written you produce methanol, and that can be sold on the market and could be used as a feedstock for other chemicals. As another process, you produce a melted slag with all these advantages. Gasifiers, small and compact systems. And you have very small emissions of this process. Yes, but however, the pre-treatment is required. Next. This is an example of a pre-treatment for mixed organic waste. It is a little bit complicated, of course. Next, please. Yes, summary and outlook. In Germany, we need thermal procedures for the waste treatment to make a recovery of energy possible, and in addition, they can be used as material recycling. These thermal procedures. So the legally demands ratios will be achieved. We have two processes in the large-scale operation. Next, please. One method is the Conterm process with approximately 100,000 tons of waste per year. It's a pyrolysis plant, and it is a pre-treatment of waste for a later co-incineration of these, or in other words, you transform the waste in a substitute fuel. And in the second step, you use the substitute fuel in a power plant. And we have a slag tap power plant that is very good for the incineration of this fuel, but these slag tap power plants have not the gas cleaning systems of the waste incineration, so you must have a look at the waste. The input control of the waste must be very stringent. Next, please. Another example is the SVZ plant, about 300,000 tons, 600 of solid and 600 are gasified in Germany, and they produce with this plant the methanol, and so this plant is regarded as a material recycling, or the same as raw material recycling. The SVZ plant is highly flexible, but you need a pre-treatment of the waste. Yes, the gasification plant contains three sorts of gasifier, but I think the future of this plant, the new ones, is a slag bed gasifier. So they will change in future. They must change the old systems into the slag bed gasifier, and for the future, then they will get these also this Schroeder-Leicht fraction, because they planned to raise the throughput of this Schroeder-Leicht fraction from 100,000 tons per year, about 33% to 140,000 tons per year. Next, please. Thank you for your kind attention.